if you look at anything like this, the first thing you have to understand is to identify the ones in parallel and the ones in series. Now, at this point, if you look at this, these two are in series. They are in series. And don't forget that when we say series connection of capacitor, you always have 1 over C0 equals to 1 over C1 plus 1 over C2. That's the first thing you have to do. And if you look at this, the charge is missing. The charge is missing. Now, since we have gotten this, that becomes 1 over C0 equals to 1 over your C1 is 5 plus 1 over your C2 is 15. Now, 1 over C0 will now becomes, the LCM of both of them is 15. Now, 5 and 15 is 3. 3 times 1 is 3. Plus 15 and 15 is 1. 1 times 1 is 1. So, 1 over C0 is equals to 4 over 15. Now, this 4 over 15 we have here, for me to get the C0, this 15 will go up, 4 will come down. So, at this point, to say that our C0 is equals to 15 over 4. 15 over 4 will give us, 4 and 15 will give us 3 points. That will give us 4 and 15, that will give us, okay, let me just leave it as 15 over 4. And don't forget that this thing now is in microfarad. Don't forget that. Now, since this one now, you see now is series connection, this is the total series connection. Now, for me to get the rest, this particular 20 is now in parallel. Parallel means I will add it. So the parallel connection becomes C0 is equals to C1 plus C2. And your C1 is this 15 over 4. Plus C2 is the 20, take over 1. Now the LCM is 4. 4 in 4 is 1. 1 times 15 is 15. Plus 4 in 20, 1 in 4 is 4. 4 times 20 will give us 80. 15 plus 80 will give us 95 over 4. Now, by the time we divide everything, if you divide everything now, we are going to get 4 in 9, that will give us 2, remember 1, that is 15. 4 and 15 will give us 3.75 cm. This is how to calculate the total capacitor, if you want to calculate total capacitor. But according to the question, you are asked to calculate, determine the potential difference across the 5 ohms resistor. That's what you are asked to find. And if you look at it, the 5 ohms is at the series connection. And when it's connected in series, different charge will pass through them. Don't forget that this is what we have, different charge. So the first I have to get is to get the charge first. Sorry, the different voltage will pass through them because it's the same charge, I mean. So when it's connected in series, different voltage will pass, but the same charge. Now I have to get the charge. If I get the charge, the same charge will pass through both of them. So at this point, for me to get the charge, I'll be using the series connection. And the series connection is this, which is the 15, which is the 3.75 microfarad. Don't forget that 3.75 microfarad. That is 15 over 4, which is the series connection, which is the series connection total for this, because the 5 ohms in series connection. Now, at this point, all you have to do now is this. You have to get the charge. You say that, yeah, we say V is equals to charge over current, charge over capacitor. Now, at this point, our voltage is 24. So we have 24 is equals to the charge we have there is, we don't know the charge. Capacitor is 3.75. So your charge now becomes, you multiply both of them. That means cross multiply this with times this. This times this will give us 90, which is 90 microcoulomb, because we did not convert the farad, the microfarad to farad. So it will give us 90 microcoulomb. 90, it will give us 90. Take note of that. Now, once you have gotten this 90, for me now to get the voltage in the 5, I will say V5 microfarad is equals to the charge, which is 90 over 5. That will give us 18 volts. So take note of all I've done. It's very important. Look at it. The first thing I do, this is in series connection. When it's series connection, different voltage will pass through them. But when it's parallel connection, different charge we pass through them. That is for the parallel connection. And don't forget, this is how to get the series connection. When you get the series connection, this is it, which is 15/4, that is 3.75. But if there's a total capacitor, look at it, this total capacitor. Now, since it's the same charge that we pass through the series connection, that is why we use the series calculation, the series results to get the charge. Look at it here, which is this. You can see it, the charge is 90. So since there's a 5 microfarad, you divide it 90 by 5, you get your voltage.